Here we're going to take a look at the reactions of amines, specifically the reactions of amines as nucleophiles. And when amines react as nucleophiles, they use the lone pair on that nitrogen to form a bond with an electropositive, a delta positive carbon. And that delta positive carbon could be in a variety of different compounds. And the first one of those is halogenoalkane. So we look at the reaction of amines and halogenoalkanes. Now, firstly, we have a look at a reaction that you studied in Lower 6. And that's the reaction of halogenoalkanes. I'm going to choose bromoethane with ammonia. And remember that we need 2 mole equivalents of ammonia. And that will form our primary amine. In this case, we will form ethanamine. And we get the salt ammonium bromide. Now, the mechanism for this reaction is a nucleophilic substitution. And let's just have a quick look at what the mechanism for this reaction is. I'm going to omit the hydrogens to save time. And again, when we're drawing these mechanisms, make sure that we include lone pairs. The base of an arrow must start from the lone pair, the centre of a bond. So the lone pair of the nitrogen is used to form a bond with this delta positive carbon, and as this bond starts to form, the carbon-bromine bond starts to break, and that gives us the following intermediate structure. And it's important that we put positive charge on this nitrogen. And then the nitrogen gains its lone pair back due to the NH bond breaking. And the reason that happens is because a second ammonia comes in and acts as a base and pulls that hydrogen off. It must be said that this step is not actually a marking point. It's simply this curly arrow which is required. And that will produce then, that will reform that will form the primary amine. And the important thing to note there is that the nitrogen gets its lone pair back. And this lone pair here can be then used to react with this delta positive carbon if we've got any excess of this halogenoalkane. So the lone pair on the ethanamine, this lone pair here can be used to attack this delta positive carbon, and we get the following reaction. So the bromoethane now reacts with ethanamine. And what happens is that this hydrogen here is going to be lost. That's going to go off with this Br, and then this CH3CH2 will take the place of this hydrogen. So that will form our product, which is diethylamine, and we also get HBr as a secondary product. The diethylamine also has a lone pair, and if there is any unreacted bromoethane around, this lone pair here can be used to form a bond again with this delta positive carbon, and we get the following reaction. So again, this hydrogen here will be lost with the bromine, and this CH3CH2 will take the place of this hydrogen. And we get the following. We get triethyl amine. And the triethyl amine, again, has a lone pair. And that lone pair there can be used to form a bond with the delta positive carbon here. And that gives us the following reaction. And we get a quaternary ammonium salt. The reaction now stops because the nitrogen has no lone pair. And we get this. This is the quaternary ammonium salt, and the bromine now is my counter ion. And I just have one product. So this here would be called tetraethyl ammonium bromide. And these are quite useful because these are what we call cationic surfactants. And these cationic surfactants can be used, for example, in hair products. Which is one of the uses that you need to be aware of. So again, the key thing to note there is that if you want to produce this quaternary ammonium salt, the key condition is you will need an excess of the halogenoalkane. So if you want to produce the quaternary ammonium salt, you must have an excess of the halogenoalkane. Okay, and again, we get these nucleophilic substitution reactions where we get multiple substitution products, and eventually we end up with this quaternary ammonium salt. Now, we're going to have a look now at amines with another compound which has got a delta positive carbon, and that is amines reacting with acyl chlorides. Now, this topic is covered in more depth in carbonyls, specifically in the chapter on acyl chlorides, but we'll have a quick look at it here. And I'm going to use ethanoyl chloride and methyl amine. And what happens is that this hydrogen is lost with the Cl to form HCl, and the CH3CO then becomes attached to this CH3NH. So in effect, the nitrogen here will become bonded to this carbon here. And that will form the product which is called an N-substituted amide. So we're going to have a look at the mechanism for this reaction now, and hopefully we can remember that this mechanism is called a nucleophilic addition elimination mechanism. So again, base of an arrow has to start from a lone pair at the centre of a bond. So the lone pair in the end is used to form a bond with this carbonyl carbon. As this bond starts to form, the pi bond will break and we get the following intermediate structure. We call it a tetrahedral intermediate because there are 4 bonds to this carbon. So in this intermediate structure, you've got to make sure that you've got your lone pair on the N, so lone pair on the oxygen, sorry, and a negative charge and a positive charge on the nitrogen. Then we need 3 curly arrows, one from the lone pair on the on, reforming the oxygen carbon double bond, from the centre of the Cl bond to the chlorine, and the centre of the NH bond to the N. So remember that when bonds break heterolytically, the pair of electrons will always go to the most electron-negative atom. And that will form our product, which is an N-substituted amide. And we also get HCl. So the name of this product would be, when you look at what the alkyl group is attached to the nitrogen, and it's a methyl group. So this would be called N-methyl. And the functional group, when you've got a carbon double bond oxygen nitrogen, this is an amide functional group, and you've got 2 carbons in this amide, and therefore this is N-methyl ethan amide, N-methyl ethanamide. So this nucleophilic addition elimination mechanism, you should be aware of whether the nucleophile is a primary amine, as it is here, ammonia, water, or an alcohol. The final reaction we'll look at is when amines react with acid anhydrides. And we'll look at ethanoic anhydride and methylamine. And whether you react acyl chlorides or acid anhydrides with methylamine, you will always get one of the products being identical, and it's always the main organic product. So this is also formed in this reaction. We get N-methyl ethanamide. But instead of HCl being my other product, I get ethanoic acid. So when anhydrides react with primary amines, we always get an N-substituted amide and a carboxylic acid. Let's just have a look at this reaction. Well, my acid anhydride has got the following structure. And in effect, what's happening is now this mechanism is not on the specification, but if we have a look at it, will hopefully help us understand what's happening. I'll put the hydrogens on the other side. In effect, what happens is the mechanism is very much the same, and so that's my intermediate. So in effect, all this thing here is instead of the Cl. So as I said, I will stress this mechanism is not required, but I'm showing it to help you realise that acid anhydride reactions are quite straightforward. And again, this is what happens, and we get exactly the same product form. We get this N-methyl ethanamide, but this hydrogen here will tag on with this bit here to form the ethanoic acid. So the ethanoic acid comes from here, and the N-methylphenamide is there in yellow. So they are the reactions of amines. We've looked at amines with halogenoalkanes. We need to remember this idea that once we get the primary amine formed in the reaction of ammonia and a halogenoalkane, that primary amine can react with any excess halogenoalkane to form secondary, tertiary, or the quaternary ammonium salt. And the reactions of amines with acyl chlorides and amines with acid anhydrides, we've briefly looked at it here, but it is something that you can look at again in the specific videos on acyl chlorides and acid anhydrides. So there are the reactions of amines.